There is a river on Earth that doesn't flow across land. It doesn't reflect sunlight, it doesn't have visible banks, and it doesn't end where rivers are supposed to end. Instead, it continues beneath the ocean. This hidden river is part of the Congo River system, and it flows through a place known as the Congo Submarine Canyon, one of the deepest, longest, and least understood underwater landscapes on the planet. For most of human history, no one knew this place existed, not because it was hidden on purpose, but because it was impossible to see. Off the west coast of Central Africa, the Congo River reaches the Atlantic Ocean after traveling thousands of kilometers through forests, wetlands, and dense terrain. Like all rivers, it carries pieces of the land with it: soil, sand, minerals, and organic matter.
Normally, when a river reaches the ocean, it slows down. The sediment settles, the water spreads out. But the Congo River doesn't follow that rule. As it reaches the edge of the African continent, the seafloor suddenly drops away, and instead of stopping, the river falls. Beneath the surface lies a massive canyon carved into the earth over millions of years. In some places, this canyon plunges more than 4,000 meters deep, deeper than the Grand Canyon and far beyond the reach of sunlight. Inside this canyon, something extraordinary happens. The Congo River continues to flow underwater. At first, this idea sounds impossible. Water flowing inside water shouldn't behave like a river. But the difference is weight. The Congo River carries one of the highest sediment loads of any river on Earth. Mud, sand, and organic material from the rainforest saturate the water, making it heavier than the surrounding seawater. When this dense river water reaches the edge of the continental shelf, gravity takes control. The river sinks. It slides beneath the lighter ocean water and begins flowing downhill along the seafloor, pulled forward by its own mass. Scientists call this type of flow a turbidity current, but the Congo turbidity current is unlike almost any other known example.
For a long time, oceanographers believed oceanographers ended at the coast. Underwater, they expected chaos, swirling currents, mixing water, energy loss. So when early sonar scans showed what looked like river channels on the deep ocean floor, scientists assumed it had to be something else. Some thought it was caused by earthquakes. Others blamed landslides. A few believed the maps were simply wrong. But the patterns kept repeating: straight channels, sharp turns, deposits layered like riverbanks. The only explanation left was the one nobody wanted to accept. A river was still flowing. To confirm it, scientists deployed sensors directly into the canyon, a risky move. These instruments were crushed by pressure, dragged kilometers from their drop points, and in some cases, completely lost. But the ones that survived told a shocking story. They recorded sudden bursts of movement, with dense water rushing past at high speed, sometimes weeks after heavy rainfall thousands of kilometers inland. That meant something impossible was happening. Rain in Central Africa was triggering motion deep beneath the Atlantic Ocean.
Most underwater flows weaken quickly. They slow down. They fade. The Congo flow does the opposite. Once it begins moving, it accelerates. Measurements taken by oceanographers show this underwater river reaching speeds faster than many surface rivers on land. And more importantly, it doesn't stop. It continues for hundreds, sometimes thousands of kilometers beneath the Atlantic Ocean, carving channels, reshaping the seabed, and transporting material far from land. Among the material it carries are entire trees. Trees that once stood in the Congo rainforest have been discovered deep on the ocean floor, having traveled through this dark underwater corridor. Imagine a tree growing deep inside the Congo basin. It lives for decades, maybe centuries. One year, heavy rainfall causes flooding. The riverbanks collapse. The tree is uprooted and carried downstream. It travels through rapids, past villages, through winding channels, until it reaches the ocean. But instead of floating away, it sinks. Dragged by the dense underwater river, it descends into darkness. No light, no oxygen, just pressure and cold. Years later, that same tree is discovered thousands of meters below the surface, perfectly preserved, resting where no forest should exist. That journey crosses ecosystems, climates, and physical laws most people never think about. And it happens more often than we realize.
What the Congo River carries doesn't disappear. It ends up spread across the deep Atlantic basin, forming massive sediment fans on the ocean floor, some of the largest geological structures on Earth. Inside these layers are chemical fingerprints of Africa itself, dust from ancient forests, organic material from long-extinct plants, clues about climate changes that happened thousands of years ago. In fact, scientists studying these deep-sea deposits can reconstruct Africa's climate history without ever setting foot on land. The underwater river has quietly archived Earth's past. Every flood season adds a new page. Every surge rewrites the seafloor just a little more.
The flow feeds itself, maintaining momentum over vast distances. In effect, the Congo submarine canyon acts like a natural pipeline, one that has been operating continuously for thousands of years. And this invisible river doesn't just affect geology, it has reached into the modern world. Lying quietly along the ocean floor are the fiber optic cables that carry global internet traffic between continents. Several of these cables pass near the Congo submarine canyon. Over time, some of them were mysteriously severed. At first, the cause wasn't clear. There were no earthquakes, no ship anchors, no obvious explanation. Eventually, scientists traced the damage back to the underwater Congo River, powerful enough to snap armored cables designed to withstand extreme conditions. All of this is happening in total darkness. No sunlight reaches the canyon floor. Pressure is immense. Temperatures are near freezing. Cameras struggle to survive for long at these depths, which is one reason this place remains largely unknown outside scientific circles. The Congo submarine canyon exists because of a rare combination of conditions. The Congo River drains a massive portion of the African continent. It carries enormous amounts of sediment, and the continental shelf along the West African coast is unusually narrow, allowing the river to plunge directly into deep water. Most rivers don't have this advantage. That's why underwater rivers like this are extremely rare. It isn't mysterious because it defies science. It's mysterious because nature aligned its rules in a very specific way and kept them aligned for millions of years. Unlike famous legends or popular myths, the Congo submarine canyon doesn't rely on exaggeration. Its reality is enough. A river flowing beneath the ocean, a canyon deeper than the Grand Canyon, a force capable of reshaping the seafloor and disrupting global communication, all without making a sound. It's a reminder that some of the most powerful systems on Earth operate quietly, far beyond human attention. Not everything extraordinary announces itself. Some of the planet's most unbelievable places exist silently, far below the surface, moving slowly, following rules older than civilization itself. What else are we missing? The Congo submarine canyon wasn't hidden by intention, it was hidden by depth. And it raises an uncomfortable question. If something this powerful, this large, and this influential could exist unnoticed for so long, what else is happening beneath us right now? Beneath the oceans, beneath the ice, beneath the ground. Not myths, not legends, real systems operating silently, shaping the planet while we look elsewhere. The most dangerous assumption humans make is that we already know how Earth works. Sometimes the truth isn't mysterious. It's just very, very deep.